Welcome everyone to the final stop in our ISTQB Foundation Level V4 preparation series here on YouTube. Over the past 3 videos, we've been through questions 1 to 30, and now it's time to tackle the last 10 questions of our mock exam together. If you found this series helpful and you want to keep practicing, you can always enroll in the full exam preparation course, which includes 6 additional mock exams with detailed explanations. And if you'd like to go deeper, you can check out the full training course where I walk you through the syllabus in detail with a lot of quizzes and 3 more practice exams. And if you want the complete package, there is also a bundle that gives you both. Whichever path you choose, you will not only prepare for the certification exam, but also build a solid foundation in software testing, while having fun along the way. All courses are on Udemy and links are pinned in the comment section. Awesome. Let's begin today's journey with question number 31. The question says, which of the following is an example mostly justifying the importance of the test plan? As always, 4 options are provided. A. Evaluating and providing feedback on the current test phase. B. Helping stakeholders evaluate the overall test results and defects. C. Determining whether a function of a system is working as expected. And lastly, option D. Documenting methods to be followed to achieve test goals. Pause now if you want to think about it. Awesome. Let's analyze each option. So, option A seems like an incorrect choice because evaluating and providing feedback on the current test phase is more about test monitoring and control activities, not the primary purpose of a test plan. A test plan is created before execution, not just to evaluate progress. Now, if you look at option B, we can find that it's also incorrect. You see, helping stakeholders evaluate the overall test results is part of the test completion activity. A test plan does not directly provide that. Next, option C is not correct, of course. This is obviously the purpose of test execution and defect logging. Now, we're left with option D, which should be hopefully the correct answer. And indeed, it's the one. This statement precisely describes a benefit of a test plan because a test plan is meant to document the methods, approaches, and resources required to achieve the testing goals and objectives. A test plan is what provides structure, guidance, and alignment for the entire team before testing even begins. So, I believe option D is undoubtedly the correct answer to this question. And now let's see what we have next. So the next question is number 32, and it says, your team is estimating a new software using 3-point estimation techniques. The following estimates were made. The most optimistic estimation is 4 working days. The most pessimistic estimation is 16 working days. And the most likely estimation, 10 working days. What could be the final estimation? A. Between 6 and 10 days. B. Between 8 and 12 days. C. Between 14 and 18 days. And lastly, option D. Between 2 and 6 days. Pause the video and take a moment to do your math. Alright folks, so this is a simple math problem, and to be able to answer this question correctly, you need to recall the equations for the 3-point estimation technique. And according to my calculations, the correct answer is option B, between 8 and 12 days, and here's how. We first should calculate the estimated effort, which is 10 working days. Then we should calculate the standard deviation, which is 2 working days. This means that our estimation should be between 8 and 12 days. Of course, if your math matches mine, you've got it right. Well done. If not, you can pause the video, go back over the equations, and check your calculations before moving on. Let's now encounter the next question. Now, let's shift gears toward question number 34. And that's a classic test case prioritization problem, so let's take a quick look at this one. Considering these requirements of banking applications, these requirements are traced back to their test cases, and some of these test cases are dependent on other test cases. Then, we're provided with this nice looking table. Also, we're provided with some instructions for testing. These instructions are: 1. Functional testing is to be conducted before non-functional testing as they are of a top priority. 2. All non-functional testing is of low priority except penetration tests, which are high in priority, but still lower in priority than any functional test. Now, the question is challenging us to figure out the best order of test execution. Pause now if you want to think about it. Alright folks, let's try to solve this one. So we're giving a table that lists several test cases that are tied to some requirements. Of course, some of these test cases depend on other test cases while others are independent. Now, the best thing to do is to classify these requirements so we can understand their priority. So, users' data privacy is obviously a security test. The ability to log in and applying for loans are functional tests. Test case 4 is definitely a performance test. Ensuring the app is using an encrypted connection is again a security related one. And lastly, retrieving the account balance is for sure a functional test. From this point, it's better to assign priority numbers to each test type. So, functional tests are given a priority number of 1, which is the highest priority. Then, all security related testing are given a priority number of 2, and other non-functional tests are given a priority number of 3. That's awesome, because things are pretty much straightforward now. I guess we have 3 functional tests that should be executed first: test case 2, test case 3, and test case 6. Now, test case 3 depends on test case 6, and test case 6 depends on test case 5. Now, when it comes to test case 2, it depends on, again, test case 5. So, it makes sense to start with test case 5. After test case 5, we can run test case 2 or test case 6. Both are functional, so they are equally high priority. And once test case 6 is done, we can execute test case 3 since its dependency is satisfied. This leaves us with only test case 1 and test case 4. Now, test case 1 is a security test, so it takes priority over test case 4, which is a performance test. So in this case, test case 4 would be the last one to be executed. Putting all together, the correct order of execution should be test case 5, then test case 2, then test case 6, then test case 3, and then test case 1, and finally test case 4. And that matches option A as the correct answer. Let's see what we have next. Great. Let's shift gears to question number 34 and let's read it together. Consider the following test cases for a weather application. Test case 1. Open the app, change settings for temperature from degrees Fahrenheit to degrees Celsius, and verify the correctness of the temperature units displayed to the end user. Test case 2. Open the app, ensure an internet connection is available, change location, and verify that the temperature updates in less than 1 second. Now consider the following test quadrants. Q1, technology facing, supporting the development team. Q2, business facing, supporting the development team. Q3, business facing, critique the product. Q4, technology facing, critique the product. Which of these test quadrants best fit these test cases? Pause now if you want to think about it. Great. Now, in order to be able to answer this question, you need to figure out which test quadrant test case 1 and test case 2 belong to. Let's start with test case 1. This test case is evaluating one app feature, which is the correctness of data when displayed in different temperature units. This is a pure example of functional testing. So, to what quadrant does functional testing belong? Yes, test quadrant 2. Now, if we look at test case number 2, you can see that it's evaluating how fast a test object responds. This is, of course, a typical performance test. And I think we all know that performance testing belongs to quadrant 4. So, no doubt about that, and I think this is very obvious. Option B is precisely matching our findings, and that makes it the correct choice for this question. That's awesome. I think this is the mark for the lecture's halfway point. So, if you are still following along, please give this video a like. Now, let's see what question 35 is all about. Consider the following risks of an email app. Risk: when the battery is less than 5% and the user decides to turn on battery saving mode at the same time, the OS itself limits the CPU frequency in order to save as much power as possible. Impact: low. Likelihood: medium. Expected behavior: the app might not sync emails immediately. Now, among the following options, which should be the most reasonable risk control action to be taken? As usual, four options are provided and they are: A. Contingency plan, B. Risk mitigation by testing, C. Risk transfer, and lastly option D. Risk acceptance. Pause now if you want to think about it. Awesome. Let's see what we can understand from the context of this question. So basically, we're dealing with a risk that doesn't break the app, doesn't cause data loss, and doesn't really stop the user from continuing to use the application. It only delays the syncing of emails under a very specific condition: low battery and power saving mode on. So this makes it a minor inconvenience rather than a serious fault. Now, based on this analysis, I would say that option A is, of course, not correct. You see, contingency plans are meant for handling major risks that could significantly affect the project or product, and it include huge actions such as setting backup strategies or failover systems. Here, the risk is too minor to require such heavy measures. Next, option B is not a viable option for a good reason. This is because risk mitigation by testing won't really change the situation, since the behavior comes from the OS level restrictions rather than the app itself. Now, option C is a big no-no. As a matter of fact, risk transfer is about shifting responsibility to a third party, like outsourcing, insurance, or warranties. Clearly, that doesn't apply here, since this is simply an inherent limitation of the operating system. And finally, we come to option D, which turns out to be the correct answer. Let me explain why this makes the most sense. First, the risk itself is low impact and low likelihood. It's low impact because the app doesn't crash or show faulty behavior, and it's low likelihood because it only happens when the battery drops below 5%. That's not a situation users face every day. Second, This limitation comes from the operating system itself and not something the app can control or fix. In fact, any other app on the same device would behave the same way under these conditions. Third, most users already know that, when their phone battery is very low, the phone won't behave normally anyway. They expect this kind of change. Also, the user always has the choice not to enable power saving mode, and if they don't turn it on, they won't face this issue. And finally, and by common sense, users would actually prefer saving their last bit of battery over receiving emails instantly. If the trade off is between a delayed email and the phone shutting down completely, people mostly will choose battery life every time. So, with all of that in mind, I believe it's very safe to say that option D is clearly the most reasonable choice here. Let's move to the next question. Alright, so question number 36 says, how does the test progress report best contribute to the success of the test process? A. It provides information for the test monitoring and control, helping track progress, identify issues, and apply corrective actions when required. B. It's mainly used after each iteration to confirm that the exit criteria were met and to gather lessons learned for improving future iterations. C. It's created early during the planning phase to give an overview of all upcoming test activities. And lastly, option D. It's mainly used in exploratory testing to record the tester's notes about how testing was performed and what was discovered. Pause now if you want to think about it. Great. So I believe this is a super easy one, but let's go through each option as always. So option A seems like a very strong contender here. This is because during the test process, the team generates test progress reports on a regular basis. These reports help understand where we currently stand and help decision making if we deviate from what was originally planned. So, if, for example, the test progress report stated that we are 50% done executing test cases at this point, but the plan is to achieve 75% in the same period of time, that means we can, for example, hire a freelancer testers to accelerate the test case execution and return back to the required percentages. Moving to option B, and that one looks incorrect. You see, when we say an iteration has fulfilled its exit criteria, we mean that the iteration has been completed. And when an iteration completes, we generate the test completion report, not the test progress report. Now, option C states that test progress report is generated as early as possible in the planning phase, which is basically incorrect. The test progress report gets its structure defined at the planning phase. Yes. So we determine what will be included in the test progress report and how often it will be generated during an iteration or a test cycle. However, the test progress report itself is not generated during the planning phase, but during the testing phase on a regular basis as mentioned earlier. And finally, option D clearly describes the test charter, not the test progress report. Thus, it's not the correct answer. Alright, so I believe we can all agree now that option C is the correct choice here. And now, let's move to the next question. Excellent. Let's encounter question number 37. Configuration management is of a great value for the test process. Which of the following options best describes how it can achieve this claim? A. Regarding defects found, the defect report elements and the format of the screenshots to be used are all standardized in CM or configuration management. B. Regarding product quality, The level of code coverage is predetermined in the configuration management, and testers try to reach this required coverage during testing. C. Regarding product risks, the configuration management determines the level of risk quantitatively by multiplying the risk likelihood and the risk impact. And lastly, option D, regarding resources, configuration management determines the budget for testing and personnel hiring required to achieve the goal in the allowed time frame. Pause now if you want to think about it. Excellent. Let's analyze each option to determine which one is a better representation of how configuration management can support testing. Starting with option A, I would say that this is a very good contender to be the correct answer because configuration management indeed helps testers by keeping all test artifacts consistent, traceable, and under version control. That include defect reports and their included screenshots. This avoids confusion and improves collaboration. So let's keep option A in mind and let's see if there will be a better choice in the other options. Now, if we look at option B, we can immediately recognize that it's a false statement. This is because code coverage levels are determined as part of the test strategy and exit criteria, not by configuration management. Next, option C also seems like a bad option. What's described here is more of a risk analysis activity and has nothing to do with configuration management. Lastly, option D is of course not true. It's describing a fundamental test planning activity and not related to configuration management anyway. So I believe it's undeniable that the best choice here is option A. Regarding defects found, the defect report elements and the format of screenshots to be used are all standardized in configuration management. Well done, everyone. Let's move to the next question. So, question 38 says, consider the following requirements of a note manager mobile application. 1. When a note is saved, it should appear immediately in the notes list. 2. Notes should sync to the cloud within 5 seconds maximum from saving. 3. The sync feature is paused when the low power management system is activated. 4. The sync feature should function when the phone is connected to the charger. 5. Any new or edited note should appear on the top of the other notes in the notes list. Now, you're testing the application and wrote this defect report summary. The app sync feature is not working if the phone battery is 20% or lower and the network is connected to Wi-Fi. Force closing the app and reopen it again did not solve the problem. Also, restarting the device did not solve the problem. Furthermore, if a new note is created, it shows up in a random position in the notes list. Swiping down the screen to refresh the list solves the problem and the new notes appear on the top where they normally belong. Now, the question asks, which of the following options best describes this test summary report? A. This defect summary contains valid defects according to the requirements. B. This defect summary contains a valid defect as well as a false positive defect. C. This defect summary contains a valid defect as well as a false negative defect. And lastly, option D. This defect summary contains both a false negative defect and a false positive defect. Pause now if you want to think about it. Great. So, in this specific context, you as a software tester were able to identify two issues. And the question is challenging you to identify their types. Now, we have three choices to mix and match: valid defects, false positives, and false negatives. Now, valid defects are, of course, something we all know about. They are just the actual deviations from the stated requirements or specifications. In other words, behaviors that do not conform to what the product is supposed to do. A valid defect can be reproducible, traced back to a requirement, and shows that the system fails to meet its expected behavior. Now, false positives happen when a tester reports a problem, but after checking against the requirements, the observed behavior is actually correct. The system is doing exactly what the specification says, and in short, a false positive is a reported issue that isn't really a defect. On the other hand, false negatives happen when a testers fail to report a real defect. The software is behaving incorrectly, but the tester wasn't able to find this defect. That means a real problem exists, but it slipped through undetected. So, what do you think? How can we best describe our findings in such a context? Well, I would say option B is the correct choice here. We have a valid defect as well as a false positive. Let me explain why this is the case. First, let's explain why we have a valid defect. And as a matter of fact, this is very easy to explain. You see, the ordering issue is a clear violation of the requirements. New or edited notes must appear immediately in the top of the notes list. In the reported behavior, the note does not appear in the correct position until the user manually refreshes, so this is an unexpected behavior. This is reproducible, directly traceable to the stated requirements, and therefore could be considered a valid defect. Then we have a false positive. This is because the sync not working at 20% observation is actually matching our requirements. We have a requirement saying the sync feature is paused when the low power management system is activated. So, by common sense, many devices will enable the power saving modes around 20% battery or so. So, the observed pause is consistent with the specifications, and this behavior conforms to the requirements and should not be treated as a defect. Excellent. That wraps up things for this question, and now let's see what question 39 is all about. So, question 39 says, which of the following statements regarding test tools is not considered true? A. If you document defects found from testing in Google Sheets, we can then consider it as a tool supporting the test process. B. You can conduct performance testing by using non-functional tools. C. Code reviews are performed efficiently if static test tools are incorporated. And lastly, option D, test execution tools are used to execute manual and automated tests. Pause now if you want to think about it. Alright, let's quickly get into the answers. Starting with option A, I would say this is a true statement. Any application or software used to support the test process is considered a tool. So, if you think about it, when you use Gmail, for example, to communicate the results of testing, you can consider Gmail a communication tool supporting the test process. Moving to option B, I would also say it represents a very true statement. Performance testing is a non-functional test type that needs non-functional test tools to be conducted. Now, option C is also a true statement. In code reviews, we use static analysis tools such as the IDEs themselves to perform the code reviews statically without running or executing the code. Now, this leaves us with option D, which should resemble a false or incorrect statement. And thankfully, it does. You see, test execution tools are used to perform automated tests. For example, regression testing. But for manual testing, we can use other tools that document the results of the test themselves, but not to execute them. Otherwise, they will be called automated tests. So I believe it's 100% obvious. Option D is the only incorrect statement among the pack, and thus is the correct choice for this question. Now, let's move to the last question in our journey. Alright, the last question in our journey, question number 30. Let's encounter this one quickly, and when you're done, I totally recommend watching this video where I will share you one tip that helped me pass the ISTQB Foundation Level exam with a 95% score. Link in the description. Now, let's read the last question together. How can test automation tools aid test monitoring and control? A. Prepare test data required for conducting automated tests. B. Replace manual testing to save time and cost. C. Accelerate test case execution for complex tasks. And lastly, option D. Generate reports about test execution time for a test object. Pause now if you want to think about it. That's awesome. Let's discuss each option. So for option A, I guess that it's not the answer we're looking for. Yes, automation tool can help us generate test data, but this is related to test design and implementation, not test monitoring and control. Now, option B is also incorrect. Test automation tools can not replace manual testing. This is one of the misconceptions of using test automation anyway, as some might think that adopting test automation tools will eliminate the need for manual testers. You see, some activities are better performed manually, like exploratory and acceptance testing. Human judgment here is crucial, and test automation is of low value. Next, let's take a look at option C. And it seems like it's describing the benefit of test automation regarding test execution. And since we're talking about test monitoring and control, option C is out. This leaves us with option D, which should describe an added value of test automation compatible with test monitoring and control. And yes, test execution time is a metric collected during test monitoring, and this specific metric is also used to aid decision making during test control. So, no doubt about that. Option D is the correct choice to answering this question. And with that being said, we reached the end of this mini series of the ISTQB Foundation Level Practice. Congratulations, everyone. Thanks for letting me be part of your preparation, and I hope we meet again in future videos. So until the next time, have a great day, everyone. Goodbye.